Hello everyone, my name is Arun and I am here to explain the first question of TCP's 30 days of code contest. So let's see the solution. The problem statement is very clear that you have given an array of size n and you need to find the majority element having a frequency more than n by 2. Uh, you have to solve this for multiple test cases and it's guaranteed that the majority element will always exist in your input array. The test case is very small, like 20 test cases at max, and we have the size of array at max of 100 and the value of ARI can have maximum up to 1000. Okay, the example test case clearly explains you that we need to print in this case 238 because 238 have a frequency of 3 which is greater than 4 by 2, and similarly you are going to give the answer in all the cases. There are three possible solutions and let's discuss them. The first one is a pure brute force, in which let's take an example 1 1 1 2 3. So in this test case, in this solution, what you're going to do is you initialize your first two things, that is your number equal to your minus 1. Basically you are just taking some default values over them and max frequency to be 0. Till so far I have these two things. Now when I come to the first element, I will count how many times this element has appeared inside the array. So I will make a for loop and run and check how many times this has appeared. One has appeared. So you can see the one has appeared exactly 3 times. So the first these two defines what? Frequency I am initializing to 0. Frequency will be 0 and your x will be 1. Okay, x will be 1. Now this entire loop will do what? It will return me the frequency value of 3, basically the count of x inside the array. Count of this will be 3. Okay, so 3, and now my 3 is greater than my initially max frequency. So 3 is greater, so I will update my number to be 1 and my frequency to be 3. Now similarly I go on to this one and checking how many times this one has appeared. So it will still return me what? It will return me 3, and 3 is not greater than 3 itself. Max frequency is now becomes 3. This is your max frequency m. Max frequency m, which is 3. 3 is not greater than 3, so this will not going to work. And similarly when you come to this element, again you make a loop, check how many times this one has appeared, which comes as 3. So frequency becomes 3 and 3 is not greater than 3 itself. Again loop will not run. Then we come to 2, frequency is 1, still not work, and at this the frequency is 1, still it will not going to work. At the end I have these two values of my number and frequency, and at the last I will return the number because this is your majority element. The second test solution, we are going to use a frequency of size 1000. It's not 10,001, it's 1001. Okay, 1001, because we have given an array of size, the max element can have a value of 1000. No element can have the value of more than 1000. So I have created a frequency of size 1001 so that I can have 1000 different indexes in which I can store the elements. Some I have seen the solutions uses the maps too. It can also be work like same. Basically I want a data structure in which I can store the frequency. Maps and unordered map will also going to work in the same way. Okay, basically in my solution I am just creating an array of size 1000. Okay, And the clear reason for using a vector over maps is because it has much more fast addressing, and the space complexity will be O of n in case of maps and O of k in case of frequency. That k is also constant in this case. Okay, so 0 1, and I will make 2 and dash 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 up till 1000. Okay, initializing every element to 0. Let's take example of 1 1 1 and 2 3. So I will take what frequency, and I'm using value of array as the index itself. It means when I encountered 1 at index 1, I will update the value from 0 to 1. Then again I encountered 1, so I'll update this value from 1 to 2. Then again I encountered 1, so I will update this value from 2 to 3. Then I encountered 2, so I will update the index at 2 from 0 to 1. And when I encountered 3, I will update the index at 3 with 1. Okay, that's cool. Now I will go over this array and found which has the maximum count. The index that has the maximum count will be your majority element. It means 1 will be your majority element. And what will be the time complexity for this? Time complexity will be O of n plus k, and space complexity will be O of k. Which is constant. In case of map, in worst possible scenarios, the map have a worst time space complexity of n by 2 plus 1, which means it would be O of n. Now the third solution. This solution is pretty famous for such kind of problem, and it is called as Bayes' mode sorting algorithm, in which it would be easy for you to okay, let's see. First of all, I will going to take a wrong case in which I assume that 3 is not my 3 is my majority element. I know it's not true, but I am assuming that 3 is majority element. This states that if 3 is the majority element, then with each 3 I can cut one element of the array, and at the last I must have at least 1 3 left. Then 3 is the majority element. So if I cut 3 with this 2, and again this 3 with this 1, I don't have any 3, no more 3, and still I have some element that are not 3, and hence it cannot be your majority element at all. If I consider 1 as my majority element, I can cut 1 with 1 2, I can cut 1 1 with 1 3, and 1 1 with 1 3. Still I am left with some 1s, and hence 1 could be my majority element. Okay, and let's see how I have implemented this in the code. Let's see 1 1, let's say 2 on the first, and then 3, and then 1. I think this would be a better case to understand the solution. So if initially I have taken my first element and considered this as my majority element, so my number will be 2, which could be a majority element, and its frequency I have defaultly taken as to be 0. Okay, When I first encountered this number, I'm iterating from 0. If you are iterating from 1, then you can consider the frequency of this element. Currently I am starting with 0, so I have taken the frequency to 0. I encountered 2, so the frequency, I think I should take it here because there should be a lot of cutting. Okay, I encountered 2, so I will update the frequency to 1. Then I encountered 1 which is not equal to 2. What I'm going to do is I will just uh, cut down the frequency to 0 because I got something that is not equal to a majority element. And since my frequency reaches to 0, it means 2 cannot be your majority element at all. So I need to change my element to 1. So I'll change this to 1. And I encountered 1, so I change this frequency to 1. Basically, this case I'm changing my max most frequent element to the current element and frequency to 1. Then I encountered next one. What I'm going to do is I will, which is equal to my majority element consideration, so I will increase my frequency to 2. Then I encountered a 3 which is not my majority element, so I will decrease my frequency to 1. Okay, then I encountered a 1 again, so I will increase my frequency to 2. And at the last I have this left, and hence n equal to 1 will be my majority element. And what will be the space and time complexity? Space complexity will be O of 1 and time complexity will be O of n square. This is pretty O of n. It will be O of n. We are where is the tracer? It is O, space complexity will be O of 1 and time complexity will be O of n. Because we are iterating over that exactly once, and with these three conditions I am calculating my majority element. Okay, I hope you understand this question well, and thank you.